Chapter 7 is about right triangles and right triangle trig. We start off by seeing if we can tell from the three sides whether a triangle is a right triangle. Remember, we use c squared equals a squared plus b squared, the Pythagorean theorem. So in this case, what I need to know is how is 30 squared related to 24 squared plus 19 squared? Because remember, our longest side would have to be c. That comes out to be 900, and this comes out to be 937, so it is less. So no, it is not a right triangle. Actually, it is an acute triangle, since c squared is less than a squared plus b squared. When I compare 8.5 squared to 7.5 squared plus 4 squared, I see that they're both 72.25, so therefore they are a right triangle. Here I've got a rectangle. It says my length is 6 centimeters and my width is 3 centimeters. It wants me to find the diagonal. I know this is a right angle since this is a rectangle, so I will use my Pythagorean theorem, and I end up with the square root of 6 squared plus 3 squared, which is the square root of 45, reduces to 3 times the square root of 5, or about 6.71. The perimeter of a square is 20, so I've got this square. I know that all sides are equal, and the perimeter is 20. Well, perimeter is simply 4 times the side length. So S is 5. If I'm looking for my diagonal, and I know that S is 5, then my diagonal is equal to the square root of 5 squared plus 5 squared. That is the square root of 50, or 5 square roots of 2, which is approximately 7.07. The length of the side of a square, or find the length of the side when the diagonal is 4. So once again, we use Pythagorean theorem. We see that 4 squared is equal to s squared plus s squared. So 16 is 2s squared. And so 8 is s squared. S is the square root of 8. If I want to simplify that, since 8 is 4 times 2, we know the square root of 4 is 2. So 2 square roots of 2 is s, which makes it approximately equal to 2.83. In this one, I have an equilateral triangle. Side is 6. We know that the altitude actually divides this into equal parts. Therefore, notice that this is not drawn to scale. So I'm still just using Pythagorean theorem. My altitude in this case will be the square root of 6 squared minus 3 squared. The square root of 6 squared minus 3 squared is the square root of 27, or 3 square roots of 3, which comes out to be approximately 5.2. I have a wall with a 20-foot ladder, and that 20-foot ladder is 8 feet from the base. Once again, you can see this is not drawn to scale. It wants to know the angle the ladder makes with the ground. So remember, we're going to start using our trig functions here. But when we're finding an angle, we do inverse trig function. So x degrees will be equal to, I've got the adjacent and the hypotenuse. That would be the cosine inverse of 8 over 20. So x is approximately 66.4 degrees. At a point on the ground 50 foot from a tree, so 50 foot from a tree stands there. It says the angle of elevation to the top of the tree is 53 degrees, and it wants to know how big that tree is. So in this case, I'm looking for a side. So when I'm looking for a side, I notice opposite and adjacent. So the tangent of 53 is going to be equal to the opposite over the adjacent. So here, when I multiply by 50 times the tangent of 53, I end up getting approximately 66 feet. From the top of a lighthouse, so I've got a lighthouse here from the top, and it's 210 feet tall. The angle of depression is 27. Remember, we measure angle of depression from a parallel to the ground, which means that this angle down here will also be 27, and I'm looking from the distance to the lighthouse at sea level. And so what I need to do is find the tangent of 27 is 210 over x. Remember, if I put that over 1, cross multiply and divide, my x is going to be equal to 210 divided by the tangent of 27, which is approximately 412.15. In this one, I'm looking for an angle, so we use our inverse trig function again. In this case, I'll use the tangent inverse of 19 over 27, which is approximately equal to 35.1. In this one, I'm looking for a side, so I'm going to use cosine of 41 since I am looking for the adjacent, and I know the hypotenuse, and so that is approximately equal to 24.2. Here I'm looking for an angle again, so I'm going to use the inverse sine of the opposite over the hypotenuse, and that is approximately equal to 18.1. For this one, I'm looking for angle again, so I'm going to use the inverse tangent because I have the opposite and the adjacent, and that will approximately be equal to 64.4. Last thing we did in this chapter was solve for triangles. That means find all angles and all sides. This says that C is 90 degrees. It tells me that side A is 12 and side B is 5. So if I remember my Pythagorean triples, that's going to make side C equal to 13. And if side C is equal to 13, I can find the measure of angle A by using the sine inverse of 12 over 13, which is approximately 67.4. I can find the measure of angle B by saying 90 minus the 67.4, which is approximately 22.6. So I have all angles and all sides. For number 14, once again, I'm solving a right triangle. I know that because angle A is 44 and angle B is 46. That adds up to be 90, which makes angle C 90. I can get the measure of angle C. It tells me that measure of angle B is 6, and I need A or side C. Side C angle, the sine of 46 degrees will be equal to 6 over C. And so when I cross multiply and divide, C will be equal to 6 divided by the sine of 46, which is approximately 8.3. And I will be able to find A then by using tangent of 44, and that's equal to A over 6. So A is 6 times the tangent of 44, which is approximately 5.79. I have two more here to go. It tells me angle C is 90 degrees. Angle B is 58 degrees, and therefore I can find angle A by measure of angle A is equal to 90 minus 58, which is 32 degrees. And so I have that A is equal to 42, C is equal to 60, and therefore all I'm really finding is B, and I will have it all. So here I can use either one, 32 or 58. Since it gave me 58, I'll use that. So the sine of 58 is equal to B over 60, and therefore B is approximately equal to 60 times the sine of 58, which is 50.2. And now my last one, I've got the measure of angle A is 43, B is 47, those add up to be 90, so C is a 90-degree angle. Measure of B is 23, C is 26, so all I need is A. So the sine of 43 degrees is equal to A over 26, so A is approximately equal to 17.7.